Hello everyone, and welcome to our class video about the area of a regular polygon. Our learning goal is that you'll be able to calculate the area of, gasp, a regular polygon. Imagine that. Okay, so we've already done some problems of this type before, but in this video we'll be taking our learning a little bit farther. So let's look at an example. So for our first example, let's find the area of this regular pentagon. It has sides of 7 centimeters, and we know because it's regular that all of the sides would be 7 centimeters, as well as all the angles would be congruent. Okay, so I should probably follow the area formula, which is area equals 1/2 AP, where P stands for the perimeter, and A stands for the apothem. No, not a possum, apothem. See, there's a TH in there, apothem. Okay, so unlike the animal, the apothem is a segment that goes from the center of the polygon to the midpoint of one of the sides. In all the problems we've worked finding the area of a regular polygon up to this point, you've been given the apothem. Now here it's not given. So the main point that I want you to get out of this video is how to find the apothem when you don't know it. Okay, so let me walk you through a few steps. The first step is to draw the apothem and a triangle around it. So now here's the triangle that I'm talking about. I'm going to connect the center of the pentagon to the two vertices on either side. Now, how does that help us? Okay, well, consider this. We know that one side of the pentagon is 7 centimeters. That means that this half of the segment is 3.5 centimeters. So I know one side of that triangle already. So if I knew that angle up there, then I could use trigonometry to find the value of A. That's what we're going for. Alright, so our second step is to find the measure of that central angle and then divide it in half. Here's what I mean. So I'll draw in the rest of the triangles. So because there are 5 sides, there are 5 triangles that extend from the center of the polygon. If I rotate all the way around the center, that's 360 degrees. So to find one central angle, I could divide 360 by 5. So the measure of one of those angles in the center is 72. Now, that's not the same as the measure of the angle that I'm looking for. That 72 is the measure going across both of those right triangles. So dividing 72 in half would give me the angle that I want, which is 36 degrees there. Okay, now I've found the angle, and now I'm prepared to use trig. So we'll use trig to find A. Alright, so think SOHCAHTOA, and let's go. So 3.5 centimeters is the opposite, and the apothem is the adjacent. So that would indicate to me that the function that I want to use is tangent. Remember, that's the TOA part. Alright, so having picked tangent, let's fill it in. So the tangent of my angle is 36 degrees, the opposite is 3.5, and the adjacent is A. Alright, let's just walk through and solve it. If I put tangent of 36 in the calculator, that's 0.726. Then I'll multiply both sides by A to get it out of the denominator. So I'd have 0.726A equals 3.5. Dividing by 0.726, I would have A equals 4.81 centimeters. Okay, so my apothem is 4.81. Now that I have that, well, I have all the information I need to find the area. So let's use our handy-dandy formula. So the apothem is 4.81, and the perimeter, since all the sides are 7, is 35. So my final area is 84.30. Oh, don't forget your units. If you don't write them, I could assume it's anything. Like, it might be 84.30 hippopotamuses. Okay, well, anyway. So we walked through that whole example. Let's do one more to make sure that you've got it down. But before we do that, time for a little math joke. So, what did the mathematician say when his pet parrot flew away? Polygon. Okay, sorry, I'll move on. Alright, so here's example 2. Let's find the area of this regular hexagon. Do you think you could do it on your own? Here's the steps again. Try pausing the video to find the area of the hexagon by yourself. Then you can check with what I got. Okay, so let's do it. For step 1, I'll draw the apothem, and I'll go ahead and draw all of the triangles that are in the hexagon. There's 6 of them this time. Okay, I need to find the measure of the central angle. So I'll do 360 divided by 6 triangles. So that measure of the central angle is 60 degrees. So the half of it is 30 degrees, and that's the angle that I'll use when I'm finding the apothem. Okay, then I'll need to use trig to find A. So half of the 8 centimeter side is 4 centimeters. So the 4 centimeters being the opposite and the apothem the adjacent, again my choice is tangent. So I have tangent of 30 equals 4 over A. Tangent of 30 is 0.577. Then multiplying both sides by A, I'd have 0.577A equals 4. Divide both sides by the 5.77, and don't forget, use all the decimal places in the calculator by using the answer button. And then I'd conclude that my apothem is 6.93 centimeters. Okay, so since I know that, I can find the area now. Using our handy-dandy formula, I'd have 1/2 of 6.93 times 48. The 48 is 8 times 6 because there are 6 sides to the hexagon. Okay, so my area is 166.28. And don't forget your units. Alright, we found the area of the regular hexagon. Alright, awesome possum. That's all, folks. See y'all in class.